I think I got really excited about this program because I'm not a BC person. I came out here in 1979, and 1979 through about the mid-1980s, people in the Strait of Georgia just recreational fished. That's what they did. But I clearly remember driving over Lionsgate Bridge in the 80s, and you'd look down in August and September, and there'd be 300, maybe 400 boats fishing there. You don't even know how they actually could fish. But this used to be commonplace all through the Straits, and literally gone in 2 years. So really what happened that really drove this home to a lot of us working on salmon, this is a kind of a smooth curve. This is the actual catch of coho salmon in the Strait of Georgia, and it's the recreational fishing and the trawlers. And you can see the obvious crash in the mid-1990s there. But the magnitude of it is what really, I think, sticks in my mind. So if you just looked at the period that we used to have, you're talking about 750, 800,000 coho every year on average, right? If you put Chinook into there, you're going to find numbers 300,000 to 500,000. Now you have zero retention of wild coho salmon, and your Chinook salmon catch is probably in the 30 to 50,000 range, and of course the fishery has crashed in terms of effort to actually do that. So it is a huge change. And the effect of this on the communities was the loss of about $750 million a year in the recreational fishery to local tourism, right? Just think about that number these days. So these are the actual plots of the catch. They have the coho on top that I just showed you, and you can see the average line there, the smooth line. The bottom is Chinook, and Chinook has a little bit more of a discussion about it because in 1985 there was the Pacific Salmon Treaty implemented, and so there was a reduction in the catch there. So what caused it? Of course, when you see change like this, everybody immediately thinks about it. It's fishing. It's got nothing to do with the stock. It was because fishing overfished or you didn't have enough effort. Fishing does not explain this. Fishing contributed to the immediate crash for a couple of years because when the productivity of the stocks declined rapidly, we didn't pick it up quickly enough in the assessments. So you had about 3 years that contributed to the decline of coho salmon abundance. But it does not explain why there's been no recovery, because the plot here is the exploitation rate, so that's the proportion of a year class that's actually harvested on their return. And you can see that it's well below 10%. And it's not below 10% on just one population. This is 4 of the major hatcheries in the Strait of Georgia and the 2 really high-quality wild indicator stocks in the Strait of Georgia and the Lower Fraser. So it's very consistent across the board that we have a very low harvest rate on coho salmon now, and there has not been a recovery. What really can explain it more than anything else at this time is what is limiting the marine survival of the juvenile coho salmon that go to sea. So these are the smolts that are leaving freshwater and going into the near shore environment and the estuaries. The plot here is the same group of populations. So the line at the bottom that has the yellow circles, these are the average values for the 4 hatcheries. Again, very, very low. And then you can see the 2 lines above are the wild indicator stocks. They're a little bit higher, but they're following the exact same trend, and they're obviously very, very low. So just look back to what you had in the mid-1980s, and these are the years of spawning going to sea. You had values of 10 to 15%. And what that means, every smolt leaving these populations, every one of these juveniles, for every 10 of those, you would get 1 or you get 15. Put it in hundreds. For every 100 smolts, 10 adults back or 15 adults back. Currently, our return is under 2%. All right? It's actually You draw that line across, and you're talking about 1 to 1.5% return, right? So there's clearly a change in the ecosystem in the Strait of Georgia that we don't really understand there. Well, did it only happen in the Strait of Georgia? And this, of course, is when we started looking around in the Salish Sea. The answer to this simple question is no. And so some of the work that Mike has done through Long Live the Kings, on the left side is Puget Sound and the Strait of Georgia, and without doing a lot of the detail here. So this is coho marine survival, and you can see that there's a very substantial overlap. Puget Sound did very, very similar things to the Strait of Georgia, but it is different from the outside populations where we talk about west coast of Vancouver Island or along the coast of Washington and Oregon. If you look at Chinook, little bit more variation in the marine survival on the left. Same sort of signal on the right when you look at the outside populations. So the Salish Sea had a very common effect on both Chinook and coho. But what is really interesting when you start talking to people publicly is it's not just those two species. You're talking about ecological changes that are very, very widespread. And so what we have here on the left is the populations that have gone down well, not just populations, we're talking about parameters that have gone down. Fraser sockeye, that of course is the Cohen Commission, long-term decline in productivity until the last couple of years. Steelhead, for many of the anglers who realize that very poor productivity. Herring populations, the total abundance of herring is very variable, but what you've lost is the number of the spawning locations, and they have really gone down over time. Forage fish, like Oolican in the Fraser River, enormous crashes in that, and a little bit of recovery in recent years. Pacific hake, ling cod, and kelp. The most common observation when we met with the public around the Strait of Georgia was the loss of kelp beds, right, throughout the entire strait. And that, I think, is expressed. Now, it's not all downhill because some of the other things that could cause a decline are the explosion of harbor seals. And you'll see some of that in the description of the programs. Pink salmon. How much do pink salmon compete with salmon for food? Because they're the earliest salmon, other than spring Chinook. They're the earliest salmon out into the marine environment. And of course, they're very large, very abundant right now. Water temperature in the Strait of Georgia, throughout the entire water column, over a 1 degree Celsius increase over 30 years. Sounds small, but huge when you look at the biological effect of that in terms of energetics. And us. What about us? The population around the Strait of Georgia continuing to increase, and if you look at the cosmopolitan area from Seattle north up to Vancouver, still projecting a continuous growth of another 10 million people over 20 years. Right, so we're part of this equation, big time. We've seen a lot of changes widely. What's really kind of almost dumbfounding to me is why there's been no real response. There have been studies, but how do we actually ignore the effect on the communities and the change in the social value of recreational fishing like this? It's not even touching on the commercial fishing, because don't forget, in the 80s, we had a very large troll fishery that provided fresh product throughout the whole year, right? So it was a lot of fish caught. I've touched on this one. There has been lots of research, but the research has not been fully integrated, right? So nobody's questioning the value of particular studies, but you can't get to the full picture without doing a lot more. Very significant impacts on the communities. We've touched on that. And you really have to wonder why we haven't done anything, but there clearly has been, we haven't had the resources dedicated to it, and we simply haven't had the leadership to tackle the question in a really big way.
Just quickly, this is the salmon life cycle. You've all seen it. You know what it looks like. This is how we've been illustrating what we're dealing with. So as you know, we've spent a lot of time focusing on the freshwater, and wasn't until the past 20 years or so that the real the increasing focus has been on the marine environment. And it's, I'd say, less so here. There's been more effort in like the Gulf of Alaska, the Columbia River Plume area, the coast. And now, basically, here, we're in some ways trying to play catch-up. So just a little bit of background before I go into this. Long Live the Kings got involved in dealing with this issue around marine survival in 2010. I was facilitating a workshop that involved U.S. and Canadian scientists, and it was supposed to be about hatchery and wild interactions, but the questions, the issues deferred to, well, what's going on in the marine environment? That's what we don't know. And so from there, we learned about Brian's work with the Pacific Salmon Foundation and thought it would be a good idea to team up and then start something on the U.S. side. And we did that in 2011, 2012. And then at the end of 2012 is when Brian and I had put together this workshop. And we had over 90 participants. Again, they represent multiple disciplines because we're looking at this from the perspective of it's an ecosystem-based issue. We don't know exactly what the problem is. We better have broad representation here so we kind of can look at everything together and get at what's going on. We had 2 days of presentations from experts in their fields focused on what may be correlated with survival declines. Then we had a 15-member advisory panel taking up a lot of the experts from the other regions and local experts to consult and debrief, talk about what they learned from the workshop, and come up with a series of recommendations about what to do next from a research perspective. And fundamentally, the question was, well, does it really make sense to approach this from a U.S.-Canada perspective and join up? Is there enough overlap here with the issues and with approaches that it makes sense to do so? And as you would obviously, think, the answer was yes, and that's why we're here. So it does have both ecological and operational merit. As you've seen, the declines are similar on both the U.S. and Canadian side. There's other signs that this other ecological shifts are the same. Oceanography in some ways is similar, in some ways is different. I won't say the same, get me in trouble. And so there definitely was value there. Also operationally, there's just merit in collaborating. There's some strengths and weaknesses on both sides of the border. The Ricker is a great example of where we have a Canadian vessel that provides a really, really valuable data to both sides of the border. And from there, both the workshop participants and the advisory panel provided specific recommendations about what to do. And the primary recommendation was to focus on the fish and then build out from the fish, because from a cost perspective, it's a lot better to see what the fish tell you and then try to think more broadly and build from there. And then also fundamentally, because the ecosystem is built from the bottom up in many ways, obviously there are top-down pressures, it makes sense to start with a bottom-up understanding. And so that's one of the major components. There was also a strong emphasis on utilizing the existing data we have as best possible to build a picture of what is going on in the environment, and then also use new information to fill in the gaps. And then there were some recommendations on developing large-scale experiments where we can actually take out certain factors and test certain factors to see if you can get at issues. And some places experimental management works, some places it doesn't. So you have to keep that in mind. So this led to formally, after this workshop, we formally introduced the Salish Sea Marine Survival Project. As Brian and I had alluded to before, this is building on a lot of past work. It's not like we just came in and invented it. And we went through all of these for the most part. There was some other work from the Pacific Salmon Foundation on their data center for the Strait of Georgia. And then, as I said before, we did some research planning with a U.S. group through 2012 before it was merged into the project itself. And then, as Brian said again, this is the view here is that it's a fully integrated multidisciplinary approach, and we're focused on early marine survival component, not only because we see disparity in overall marine survival between the Salish Sea and the coast, but also because there's a significant amount of data to suggest that it's the juvenile component that dictates a lot of overall marine survival, and not just from the Salish Sea, but from other regions. So what are our primary hypotheses? And these are alluded to in the workshop, but I'll just go over them again. So again, the factors affecting bottom-up processes are dominating. Less prey or lower prey quality are available for salmon and forage fish. And the salmon basically aren't able to compensate. So it could be simply that the prey aren't available. It could be the salmon aren't able to respond due to changes in life history. And we're trying to get an understanding of what the scale of this is. And then top-down processes are likely contributing, especially because we're seeing survival, the mortality happen within the first few months. There has to be some proximate cause of mortality. You don't see dead fish swimming, as Dick Beamish likes to say. And then what other factors may be contributing to this problem? Disease, toxics, habitat degradation. These will all be rolled in at some level. And then fundamentally, we have to ask the question, is this something we can do something about? Is it something local? Is it associated with humans? Or can we take some sort of management action to deal with it? Or is it a global issue? And does it have to do with climate change? Or just does it have to do with natural cycles? And is there just some sort of lag, I guess, in the Salish Sea system versus the coast that's causing this weird response? So for the research activities, what we'll be doing is examining the condition of salmon and steelhead as they migrate out to determine what the fish tell us. And we didn't talk about steelhead too much before, but there is a steelhead component. It was already been enacted on the US side through a state appropriation to look at steelhead marine survival. And also analyze physical and biological characteristics that are the cornerstone of the ecosystem. And look at critical growth periods, and there's evidence to show that there's size-selective mortality. So looking at critical growth periods and that association with overall survival is very important. Perform targeted studies, again, of the different top-down pieces. And the way we're looking at this is that we'll, from a Salish Sea perspective, we're going to build a very integrated bottom-up program, but because there are so many different variables with the top-down, that we can approach those more selectively from a US-Canada perspective and make a more cost-effective approach. And then, again, we're utilizing both existing and new data in models and whatnot to kind of build the full picture. And again, if you have to build out from maybe the mechanisms that are driving survival, like food, and trying to understand what's driving that food availability, you have to kind of create this bigger picture. And so this is a Brian slide. This is just a good way of illustrating all of the facets that are involved in this type of project. And fundamentally, this is another one from Brian, that this is where a lot of our key uncertainties lie. We have some physical data. We have data about Chinook and coho, but from the bottom-up perspective, we really don't have much on zooplankton and ichthyoplankton and on forage fish. So filling that gap is very, very important.
Show you just a couple of slides to conclude. How do you measure everything in something the scale of the Salish Sea and do it all at once? The best research vessel in the world can't be everywhere at once, right? But you could use ocean gliders and follow a certain path, or you can do what we're going to try. Okay? To be everywhere at once, what we've talked about doing is applying the KISS principle. What do we have around the Strait of Georgia that's not being used is a lot of fishing boats, right? So you can now equip fishing boats with very, very sensitive oceanographic equipment that's now affordable, and so we can actually build our own sampling platforms. So our idea is that we would have 10 vessels that all exist, and we'll pay people in communities to go out and collect this information, and then we'll just simply capture it electronically, and that will be how we are everywhere at once. So we'll simply use the capacity of the communities to go out and collect some of this data. The next one, as an example, everybody hates seals. They're cute, okay, but everybody that likes salmon hates seals, right? So the big thing, of course, is people think that seals eat all the salmon. That's the cause. But we have surprisingly little data. It is true by studying poop that we know they eat salmon. And we can do this very well with DNA. There's no question about it. But the best idea came from our PhD student at UBC, who, working with a pit tag company and an engineering firm, have designed seal beanies. And these seal beanies will detect pit-tagged salmon as they're swallowed, capture that result, and the animal is likely feeding. So if it's in the water, then the electronic sensor picks that up and it just shuts down. But once it hauls out, then it knows it's in air, so it uplinks the data it's captured to a satellite, and Austin never leaves his office. He just gets it at UBC. So we'll be able to actually track the direct feeding rate. Okay, what does this all mean? One of the things that's a challenge is what you're hearing here is a 5-year, $20 million investment in our understanding of our ecosystems and how to restore the Chinook and coal production in particular. So where are we at? We have a particular advantage in Canada because of something called the Recreational Conservation Stamp. Anybody that wants to fish in tidal waters in British Columbia and retain a salmon has to pay for a salmon stamp. We were successful in getting that money back to BC last year, and so some of that will pay for the Canadian side of the research. Where we're at right now is we have half of the funding, and we have plans in Canada. We're confident that we can reach our 10 million goal, and Mike, I think, has a little further to go. But this is a big undertaking, so you're talking about lots of program activity to take this all on. And what we really want to recognize is the Southern Endowment Fund of the Pacific Salmon Commission really enabled us to get a lot of this funds together. Because this fall, the Southern Endowment Fund recognized the potential of this research and allocated $5 million over 5 years from their endowment. And that has allowed us to trip things and start getting the other donations actually in, excuse me, and making the allocation. So that's why I said in the very beginning that the Salmon Commission is a very, very important component of this program. I said that there are a lot of people involved. If we get any more people involved, we won't be able to put their logos up here. There are currently 30 collaborators in this program, both funding and active research. So when we say that this is integrated, we really do mean it. And I really do mean it. It'll be like herding cats. And that's so. To get to the very end, this is a picture of the Salish sea fishes. It's a mural at the University of Washington. It's by Ray Troll, an Alaskan artist. And I simply put this up here to represent the program, but I think the parting message of why we did this is simply that we have an incredible array of expertise in the Salish Sea. We have the people, we have the capacity in the labs, we have the vessels. We've never made the effort to put it together, and we've never had the leadership or the funds. Right? Now we do. No more excuses. But I guarantee we're going to know a hell of a lot more after 3 or 4 years than we do right now. So thank you very, very much for coming and staying with us through this time. All right? Enjoy.